Hello, I am Patrick Kajura, writer of the magazine Discourse on Science, and I'm author of the book Basic Concepts on Theoretical Physics. You can find my material by Google searching TIOKRS, that is TIOKRS. Today I'm going to be discussing just a simple discussion on the atomic structure. So please leave comments and have a discussion on this, start a discourse on these scientific matters. Write down your opinion and express it to the world. Tell your friends to start discussing atomic structure and to get involved in the discussion. So the atomic structure. In the center we have a heavy nucleus which is composed of protons and neutrons. This nucleus was, I believe, discovered by known as Rutherford's scattering, I think. No, I don't think it's called that, but I think Hans Gainer was working with a research student, and they were firing, I believe it was alpha particles at gold foil, and they were shocked to see that some of the alpha particles were returning back. But this was very confusing to them. At this time it wasn't believed that there was such thing as a heavy nucleus composed of heavy protons and neutrons. Alpha particle was known to be very heavy, and they believed they were firing it at very light object, so they were expecting the alpha particle to go straight through, but to their surprisement a few of them, I believe 1 in 800 or 8,000, returned back. It was later realized that it's due to the fact that the center of an atom has a very small and dense positive center, known as the nucleus, as I said, composed of protons and neutrons. The protons are what have the positive charge, and the neutrons have neutral charge. Orbiting the atom at particular states or orbits is the electron, which has negative charge. So the nucleons, which are the protons and neutrons, are composed of what are known as quarks. They are composed of 3 quarks, the proton being composed of an up and a down quark, and the neutron being composed of 2 down quarks and an up quark. They belong to a group of particles known as baryons, and a wider group of particles known as hadrons. These quarks are the fundamental particles, as well as electron, which is also a fundamental particle. The family of particles electron belongs to is known as the leptons. Leptons are all fundamental particles. There are 3 main types of lepton particles. Those are the electron, the tau, and the muon. The tau and the muon are a lot heavier than the electron, but have the same negative charge as the electron does. Now we can move on to discussing the fundamental forces. There are 4 fundamental forces within the standard model. The electromagnetic force, which works on charged particles and is responsible for the everyday forces and interactions that we experience in our everyday life, such as pulling a curtain or pushing a chair or anything that you do. Gravity is another quite often well-known force. It holds planets in orbit, and it holds the stars in their position in the galaxy. It's what attracts masses together. Then we have the strong force, which holds the protons and neutrons in the in the nucleus. And last we have the weak force, which is responsible for some actions in the sun, and as well as a few radioactive decay. These forces are mediated by what are known as gauge bosons. The strong force is mediated by what is known as the gluon. The weak force is mediated by the W-, W+, and the Z particle. The electromagnetic force is mediated by the photon, whilst the gravity is mediated by what is known as the Higgs boson, that has not yet been detected. researchers at the LHC are working hard to try and hopefully detect this particle. If it's not found, then the whole standard model, which is widely accepted, will have to be revised. Thank you for listening. I'm Patrick Kajura. Please Google search TIOKRS to view more work that I will be putting up, and the articles from the magazine Discourse on Science. Thank you.